This is the 2.5, 2.8 algebra 1 review. Basically what I want to do is just graph this inequality, and it's kind of nice when the variable is on the left. You can just follow the arrow. So the number in question is the 6. I'm just going to put that below. Then I'm going to put an open circle. Now I have to decide whether I want to shade that circle in or if I want to leave that circle open. Now since there's no bar underneath the inequality, I leave the open circle. And then I can follow the arrow to the right. So I shade to the right. But you can only do this little method if the variable's on the left. So for number 2, again, the variable's on the left. And I have a bar underneath. And this time the number in question is -7. So I'm going to circle that. Now I have to decide if I shade that bubble in, and I do because it has a bar underneath. Now, I follow the arrow points to the left, so this is a little memory help, little mnemonic, and I shade to the left. Now, this one's a little tricky. Notice the variable is on the right. So I'm going to put a 5. I'm going to put the 5 underneath. That's easy enough. I'm going to put the hash mark there, and then I'm going to put the open circle. Decide whether I fill in the circle or not. It has a bar underneath, so yes, I do fill in the circle. Now, the deal is that 5 is greater than or equal to m. If you have an extra sheet of paper, you might want to do this. 5 is greater than or equal to m. Now the deal is, to get the variable on the left, I'm going to flip this over and see what happens. Notice, m is less than or equal to the number, 5. So I have to be able to interpret that backwards 5, but I can rewrite it as m is less than or equal to 5. And that's what I'm going to do. I'm going to rewrite it as m is less than or equal to 5. And now I'm just going to follow the arrow after I rewrote it with the variable on the left. I notice the arrow points that way. Another scenario where I don't have the variable on the left. So I'm going to put my -8. I'm going to circle that. I'm going to determine whether I fill it in or not. I don't. There's no bar underneath. So I'm going to do my little trick. And I'm going to write -8 is greater than p. Watch when I flip it over. P is less than -8. P is less than -8. It's just a little helpful mnemonic. So I have P is less than -8. Arrow points to the left. After I flip the variable, open circle, and I shade to the left. I don't want to solve that inequality, so I'm going to CLT. I'm going to combine like terms. So 10x minus 2x, that's going to give me 8x plus 8 is less than 12x minus 20. So now I want to get the variables on one side. So I'm going to deal with the 8x first. What's the opposite of plus 8x? That's minus 8x. I like to deal with the smaller variable. This method doesn't work 100% of the time, but most of the time you'll get away with it. So that's going to give me 8 is less than 12 minus 8 is 4x minus 20. Now I'm going to solve for the x still. I'm going to add 20 to both sides. And that's going to give me 28 is less than 4x. Divide both sides by 4. And that's going to give me 7 is less than x. Now instead of doing the dark shading method, you can just ask yourself, the alligator's eating the x. So when I put the x over here, the alligator is still going to continue to want to eat the x. So the x is greater than 7. Number 6, it has fractions. Some people like to turn that into 0.75. You don't have. Number 7, I want to solve this big inequality. The first thing I want to do is combine like terms. So I notice that 14x plus x, 1x is going to give me 15x minus 25 is greater than or equal to 5x plus 10. I like to deal with the variables. So the smaller of the two variables is 5x. So I'm going to do the opposite of 5x, which is minus 5x from both sides. This is going to give me 10x minus 25 is greater than or equal to 10. Now I'm going to deal with the digits. So I'm going to add 25 to both sides. This is going to give me 10x is greater than or equal to 35. I'm going to divide both sides by 10. Now this will probably give me x is greater than or equal to 3.5 if you use the decimal. You just move the decimal over one spot when you divide by 10, or divide that by 5, divide that by 5, so you get 7 halves. Either 7 halves or 3.5. Number 8, I have to implement the distributive property. So I'm going to distribute the 3 across this quantity to give me 15x plus 6. Now I'm going to distribute the negative 4 across. That's going to give me minus 8x minus 4 is greater than, now I'm going to distribute the 5 across, 15x. That's going to give me plus 10. Now I'm going to combine like terms. So 15x minus 8x, that's going to give me, I believe, 7x. And then 6 minus 4, that's going to give me 2, is greater than 15x plus 10. Again, I'm going to look at the smaller of the two. 7x is smaller than 15x, so I'm going to subtract 7x from both sides. It's just a little bit more convenient to do it like this. That's going to give me 8x. That's going to give me 2 plus 10. Now I'm going to subtract 10 from both sides. 2 minus 10 is negative 8. Is greater than 8x. I divide both sides by 8. And this is going to give me x is less than negative 1. So the alligator is eating the negative 1. So when I flip it, the alligator is going to continue to eat the negative 1. Joe has two options to be paid at his new job. He can either be paid $600 per week, so that's going to give me $600 a week, or $300 for the week plus 4% commission. So I'm going to set it equal first, so find out where they're equal. And that's going to be 300 plus 4%, which is 0.04 actually, 0.04. Times some number of sales. And they want to know how many sales is going to make this more profitable for Joe. So I'm going to solve the equation first. So I'm going to minus 300 from both sides. And this is going to give me 300 equals 0.04x. Now I'm going to divide both sides by 0.04. at 7,500. So 7,500 in sales is when they're both going to be equal. So in order for this to be more profitable, he should make more than 7,500 in sales. So you want x to be greater than that amount in order for this side to be more profitable. And you could write it the other way, x is greater than $7,500. His sales has to exceed 7. This is a between problem. Notice he's going to bring between $14 and $20. So I'm going to set up the 14 and the 20. And between, I don't know if that's going to be equal to or not, but I'm going to make it equals. A little bit easier. So a movie costs $8 and candy is $2 per box. So that's going to be 2. You can put a C there for candy. And the movie's $8. It'd be nice to just have that as 8. So I'm going to solve this pretty quickly. I'm going to do the opposite of plus 8, which is minus 8. But not only do I subtract it from this side, I subtract it from this side as well. Those 8's cancel out, and that leaves me with 2C in the middle. Now 2C is less than 12, and 2C is greater than or equal to whatever 14 minus 8 is, that's 6. Now I'm going to solve this for C, and I'm going to divide by 2. So I divide this by 2, I divide this by 2. I might as well divide that 6 by 2 as well. And this means he's going to have between 3 and $6 to spend on candy alone. The implication of this is if he brings $20, he'll be able to get 6 boxes of candy. But if he brings $14, he'll only be able to get 3 boxes of candy. So he'll be able to get between 3 to 6 boxes of candy, depending upon if he brings $14 or $20. I have 11, 12, and 13. I like these compound inequalities. They go pretty quickly. I'm just going to drop a 3 here. I'm going to drop an 11 here. Draw my circle. Draw a circle. And decide whether or not I fill in that circle. No bar underneath the inequality. So I'm going to leave that as an open circle. No bar under that inequality, so I'm going to leave that as an open circle. And then x is between. So the idea is all I really have to do is shade between the 3 and the 11. It's pretty smooth. Pretty smooth. This one, I think that's a poor choice of words using an and statement, but we'll see how it works out. Negative 2, so I'm going to go to the left and put my negative 2 because I know negative 2 is to the left of 4. Neither of these has a bar underneath of it, so it's going to be open. And notice it says p is less than negative 2, so that means I'm going to shade to the left of negative 2. And then I'm going to shade to the right of 4. The arrow points to the right. So technically this isn't an and statement. When they face out, that the word should have been or. Common mistake. This is another between problem. Notice the w is between the negative 5 and the 6. So I'm going to place the spot here for my negative 5. I'm going to place the spot for the positive 6. And then I'm going to determine whether I shade in those circles or not. Now, for the negative 5, it doesn't have a bar underneath it, so I leave that circle open. However, the 6, it has a bar, so I shade that. But again, it's between, so I'm going to shade between those. And this would be considered an and statement. Number 14, I want to solve this compound inequality. It's an and statement, so usually when I see an and statement, I get the idea that it's going to be shaded in the middle. Okay? So I'm going to solve this separately. I'm going to add 6 to both sides. That's going to give me 3w is greater than or equal to negative 6. Then I'm going to divide both sides by 3. That's going to give me negative 2. And 3w is bigger than negative 2. Or you can write it this way, w is greater than or equal to negative 2. Not done, I have to continue with this. So I'm going to add 4 to both sides. That's going to give me 3. For number 15, I want to do the opposite of divide by 3. So I'm going to multiply everything by 3. And when I do that, that gives me 12 is less than. Now this 3 cancels out with that 3. 2x plus 1 is less than or equal to. 3 times that is 21. So now I have to subtract 1 from everything. So that's going to give me 11 is less than 2x is less than or equal to 20. And now I'm going to divide everything by 2. That gives me 11 halves, or 5.5, is less than x, is less than or equal to 10. Alright, this or statement, I want to solve the left side, so I'm going to subtract 3 from both sides. And that's going to give me negative 7w is greater than or equal to 35. Now this is a common error with these problems. I'm going to divide both sides by negative 7. And when you divide an inequality by a negative, or multiply it by a negative, that symbol goes the other way now. So this is going to give me w is less than or equal to negative 5. W is less than or equal to negative 5. I'm not done, I have to continue and solve this side. So I'm going to subtract 5 from both sides. And this is going to give me 8w is greater than or equal to 24. Notice now, I'm not dividing by a negative 8, I'm just dividing by an 8. So that's going to give me w is greater than or equal to 3. So this is an or statement, and I'm going to end with an or statement. For 17 and 18, I'm just going to go off the worksheet. You're not allowed to drive less than 45 miles an hour. Alright, so if you're going 45 miles an hour, you're okay, but if you're going less than 45 miles an hour, so x is less than 45, you're going to get a ticket. Now if you're speeding, they're going to give you a ticket also. So that's going to be, you can't drive less than 45 or more than 70. Teen night, they want you to be a certain age, you can't have a little kid there, so they want you to be at least. So that means you could be 10, 11, 12, 13, 14, but no more than 15, but you can't be 15. So x is going to be between 10 and 15. Number 19 is an absolute value. This means it's going to generate 2 answers, or 2 equations. So I'm just going to copy down the 3x plus 5 equals 4. Then you want to put this word or if it's an equal sign. 3x plus 5 equals negative 4. Now I'm going to solve both equations. So I'm going to subtract 5 from both sides. Well, I might as well subtract 5 from both sides over here also, and get through it a little bit quicker. So it's going to give me 3x equals negative 1, or 3x equals negative 9. So we're going to divide both sides by 3. I might as well divide both sides over here by 3 as well. So this is going to give me x equals negative 1/3, or x equals negative 3. And those are my 2 possible answers. Another absolute value, I'm going to add 8 to both sides. This is going to give me absolute value of x plus 9 equals 15. The deal is you want to kind of narrow it down just to the absolute value item, and then do the absolute value step, whereas you write two equations, x plus 9 equals 15, or the opposite of that, x plus 9 equals negative 15. Then I subtract 9 from both sides, and that's going to give me my two answers pretty rapidly. So x is going to equal 6, or x is going to equal negative 24. So there's my two possible answers. Again, I just want to narrow it down and solve until I get to the 8x plus 3 before I do any absolute value move. So I'm going to minus 7 from both sides, and that's going to give me 5. Absolute value of 8x plus 3 equals, I believe, 55. 12 minus 7 is 5, so that's going to give me 55. Now I'm going to divide both sides by 5. This is going to give me the absolute value of 8x plus 3 is equal to 11. Now I'm going to go into the absolute value process. So 8x plus 3 equals 11, or 8x plus 3 equals the opposite, negative 11. I'm going to try to do it rapidly. I'm going to subtract 3 from everything. This little trick only works if you're dealing with the absolute value symbols. So that's going to give me 8x equals 8, or 8x equals negative 14. Now I'm going to run through and divide everything by 8. That's going to give me 1. And that's going to give me some fraction. So x is going to equal 1, or x is going to equal negative 7/4. And I think you're allowed to leave it in fraction form. Yeah, this time I have an inequality, not an equal sign. So this is going to be less than. I'm going to write the word and, because that says less than. And I'm going to go right into the absolute value process. So it's going to be x minus 6 is less than 10, and x minus 6 is greater than the opposite. Notice, I kind of multiplied by negative, so I have to flip the sign. Now I'm going to add 6 to both sides. I might as well add 6 over here to both sides. It just makes it go a little bit more quick. So this gives me x is less than 16, and x is greater than negative 4. And that's my two answers. They might want me to write it as an inequality, like a nested inequality. So x is bigger than negative 4. The negative 4 would go on the left, and the 16 would go on the right. And notice, the alligator eats the 16, and the alligator eats the x. So that would be the final compound inequality answer. I have another less than, so I'm going to subtract 3 from both sides. This is going to give me absolute value of 4x plus 2, close absolute value, is less than negative 16. Now, if that were an equal sign, I wouldn't be able to continue with this, but because it's an inequality, I'm allowed to keep going. It might look kind of strange, though. Here we go. 4x plus 2 is less than negative 16, less than, and 4x plus 2 is greater than 16. So I'm going to go ahead and solve these simultaneously. I'm going to subtract 2, subtract 2, subtract 2, subtract 2. That's going to give me 4x is less than negative 18, and 4x is greater than 14. Divide everything by 4, and that gives me x is less than 9 over 2, negative 9 over 2, which is negative 4.5, and x is greater than 7 over 2, which is 3.5. Let's see what this looks like on the number line. Negative 4.5, 3.5. Open circle, open circle. Notice the arrow points to the right, so this is no longer an and statement. That negative nested up outside made it an or statement. So it goes to the right of 3.5 and it goes to the left of 4.5. That's considered a trick question. Because that's a greater than sign, we're going to consider this an or statement. First thing I want to do is divide both sides by 5. So this is going to give me absolute value of x plus 8. Close absolute value is greater than or equal to 12. Now I'm going to go into my absolute value move. So that's going to give me x plus 8 is greater than or equal to 12, or x plus 8 is less than or equal to negative 12. Subtract 8 from both sides. I might as well keep subtracting 8. This is going to give me x is greater than or equal to 4, or x is less than or equal to negative 20. And if I wanted to graph that, that would be a negative 20 on the left with a closed circle, a 4 on the right with a closed circle. Notice the arrow is pointing to the right of the 4, and the arrow is pointing to the left of the negative 20.